When you start writing code, you store individual pieces of information in variables. Think of a variable as a single, isolated box. But as your programs grow, managing hundreds of separate boxes becomes impossible. You need a shelving unit to organize related information together. In Python, the most flexible way to group data is a list. Lists let you store multiple items in a specific sequence, and they allow you to store the exact same value multiple times if you need to. To build a list, you wrap your data in square brackets, separating each item with a comma. To pull an item off this shelf, you ask for its numerical position, known as its index, but Python counts starting at 0. The first item sits at index 0, the second at index 1, and so on. Lists are mutable, meaning you can add, remove, or change the items inside them after they are created. Because you can alter their contents while maintaining a strict order, lists serve as a developer's default tool for everyday data storage. That ability to easily change data is useful, but it introduces vulnerability. Sometimes your program relies on a sequence of data that absolutely must not be altered by accident while the code executes. To lock a sequence, use a tuple. Tuples organize data like lists, but are defined using parentheses. Because a tuple is immutable, attempting to reassign an item later causes Python to block you and throw a type error. By using a tuple, you sacrifice the ability to edit your data later. In return, you guarantee absolute structural security for fixed sequences, like geographic coordinates or RGB color codes. Another common challenge is redundancy. When you import large datasets, duplicate entries inevitably pile up, and writing manual loops to filter them out wastes memory and processing time. Python handles this with sets, unordered collections that reject duplicate values. Define a set by placing data inside curly braces. If you try to add an item already present, the program won't crash. The set simply ignores the command and leaves the duplicate out. Because sets have no strict order, you cannot pull items from them using a numerical index. Instead, they act as automated data purifiers, ensuring every piece of information they hold is strictly unique. Relying on numerical indexes works well for simple lists, but it falls apart when you need to look up highly specific, descriptive pieces of information across a large database. To attach labels, use a dictionary. Dictionaries use curly braces, but store information in distinct pairs. A string key maps directly to a value. Instead of remembering a numerical position, simply ask for the key by name, and Python returns the correct value. Let's test this syntax. Pause the video and open your code editor. Create a dictionary called My Car with keys for brand, model, and year. Write a print statement that outputs just the year. Here is the solution. Open the dictionary with curly braces. Each key is wrapped in quotes, followed by a colon, then its value. To isolate the year, write a print statement, reference the variable, and place the key year inside square brackets. By linking explicit names to targeted values, dictionaries mirror how we assign traits to real-world objects, making them the standard tool for generating complex user profiles. Writing effective Python is not a matter of memorizing syntax rules. It requires you to match the correct structural constraints to the specific problem you are trying to solve. If you need to build an active queue of tasks that will constantly grow and shrink, you deploy a list. If you are plotting out fixed data points that your application relies on for stability, you lock them down inside a tuple. If you have a database cluttered with duplicate entries that need rapid scrubbing, you run them through a set. And if you need to bundle related attributes to build a detailed entity, you organize them with a dictionary. This chart shows the complete breakdown. Lists provide ordered flexibility, tuples guarantee strict security, sets enforce absolute uniqueness, and dictionaries organize data by mapped labels. Choosing the right data structure allows you to build rules directly into the foundation of your code, naturally preventing bugs before they occur. Drop a comment below with a coding project you're currently working on, and let's discuss which data structure you need to get the job done.